So here we have our most simplest y equals x squared. Y equals x squared. If we can understand how y equals x squared behaves, then essentially we've understood how it behaves when we shift it up, down, across. It's not going to change very much. The most important feature of y equals x squared, of course, is this vertex here and the fact that we have an axis of symmetry. It's symmetrical. So if we have a value here, we have a value here. All right, so let's meet the cubic function. The cubic function comes in two flavors. This is the simplest flavor, y equals x cubed, and we get this shape like this. And we don't have a vertex. Instead, we have a kind of here it's curving down and then it starts to curve up. And in fact, this place where it changes has got a very special name. It's called a point of inflection. Point of inflection. However, the more interesting cubic is one like this one over here, which has got two little humps like this. Okay. Now we don't call these vertices. They have a word. They're called turning points because the function is turning here. And in fact, this one, you might guess why, is called a local maximum. And this one's called a local minimum. So we use the word local because it's not actually the maximum value. We can see this function's going on forever and there is no minimum. This one's going on forever, but just in this area here, it is a minimum, and just in this area, it is a maximum. Now, in case you're wondering where our inflection point has gone, it's still there. I'll erase some of this so we can see it. Can you see where the inflection point is? It's kind of somewhere here. And it's the place where we change from this shape to this shape. And later in the course, we'll be spending a lot of time looking at these changes. So that there is an inflection point. An inflection point. All right, so that's our basics, y equals x squared and y equals x cubed. All right, now let's consider what happens when we multiply the x squared by a number such as y equals 3x squared or y equals minus 5x squared. Similarly, what happens when we do that to a cubic? So I think the easiest way to do is to explore this under Geogebra. All right, so here is a function, y equals 1.5 by x squared. Let's see what happens when I change the number in front of it. So now it's 1.5, 1.7. Ooh, it's getting narrower and narrower. Let's now go back to y equals 1x squared. We're going to reduce it half, quarter, 0. So half. So we can see that changing the a value changes the steepness of the curve and how quickly it's rising. The bigger the number, the more quickly it's rising. What about when we go negative? Let's go negative. It's just going to do the same thing, except it's going to flip it down. So the a value is changing how quickly the function rises and thus changing the steepness of the function. How about a cubic? Let's change this to a cubic. And the principle is exactly the same. As the number gets bigger, the cubic climbs faster. As the number goes smaller, it takes longer time. And if it goes negative, notice how the cubic has flipped. It's now what I call a downy. It's going all the way down. Here it's going all the way up. All right, one more thing to think about when we're multiplying by an a value in front of the whole function. So here's a parabola, and I'm going to start multiplying. And we can see that the curve changes like this. But notice that it stays through the same positions of the zeros. Let's try and understand why. Okay. So here at this point, let's look at this point. This point is x is 4. When I put it into the original function, it lands here, which is at the value of 10. But when I multiply the whole thing by 3, it lands at 30. 430. So we can see that multiplying by 3 has taken all the y values and shifted them up by 3. Right, now perhaps you can see why the root, why the 0 here hasn't changed. Because the original function was 0. Multiplying by 3 makes no difference. Similarly over here, the original value was 0. Multiplying by 3 makes no difference. So it doesn't matter what my a value is, we're always locked on those two. So they don't change. The steepness of the function changes, and the AF can flip it, can reflect it in the x-axis, but the roots, zeros, will not change. The a value makes no effect there.